Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Nur Irwandi Mahmur. Here, I would like to present my final technology project with a title Design and Development of a Smart Mop for Cleaner, supervised by Dr. Yu Bin Seo. Mop is a floor cleaning device which is day-to-day commonly used in either in the kitchens or in the bathroom. Nowadays, hygiene is very important to all people that is conducive to maintaining health and preventing disease, especially coronavirus disease 2019, also known as COVID-19. This is due to pathogens are easily to reproduce and easily to spread due to unhygienic floors. That we can see that the baby plays on the floor at home. Once the babies play on the floor at home, they easily directly insert the things that they found on the floor into their mouth that can lead to food poisoning. On the other hand, some cleaners let the surface of floor still wet in conditions after doing general cleaning or mopping that leads to a slippery floor and dangerous for other users that step on it. Thus, this will lead to undesirable and serious accident will be occur. Based on the National Floor Safety Institute (NFSI), one of three people over 65 years of age will experience a fall annually in the United States. NFSI also claimed that falls are the second leading cause of injury-related death for people the age within 65 to 84 years old, plus 60% of deaths associated with fall involve the people who age 75 years old and above. Furthermore, when someone passes or steps on the floor that is wet in condition, the dirt or dust underfoot will again make the floor dirty. This will lead the cleaner to clean and mop the area again for the second time. By doing the repeat action, maybe wasting the cleaner working time. Here is the objective of the project. The first one is to design and develop a mop with special safety features. Second, to fabricate ergonomic prototype mop to improve the safety and decrease serious injury in daily life. And the last one is to aid cleaner to the work and decrease time taken to complete the task during cleaning process. All parts are designed in three-dimensional shape 3D with Autodesk Fusion 360 CAD/CAM software. Here we can see that CAD/CAM model for part 1, which is a pull-up bar. Next is the CAD model of part 2. It is show that a walking stick. Next, this is CAD model of part 3, which is water spray. Next, here we can see that CAD model of part 4. It is a dryer. This is a CAD model of part 5, which is a base. Here we can see CAD model of full assembly of the smart mop. On my right hand side is a front view of the full assembly, and my left hand side is the back view of a full assembly of a smart mop. When disassembled from a smart mop, it acts as a pull-up bar, which is professional strength training equipment (PSTE) for home gyms exercise. This is portable tool and can be used either indoor or outdoor physical activities. The walking stick is commonly used by older people to walk and support them during standing. This part is a combination of pull-up bar with a smart mop handle. Application on water spray. Here we can see that simulation of water spray is shown in the figure below. When water spray is disassembled from a smart mop, the liquid detergent inside will be cleaned and replaced with new water, which is allow the water spray acts as a smart irrigation. Now we can see the picture below that there is a smart irrigation simulation. This smart irrigation to water plant were commonly used in mini garden at home. The nozzle of the part 3 is now connected with an extended pipe with small hole, and at the other end of the part is fit with a stopper black in color as shown in figure below. This is due to block the water drain from that way. When the system is turned on, water will pass through the pipe and then will be dropped from the hole along the drip line. Thus, watering the plant now is only used by giving a command with our smartphone. We can customize our plastic pipe that customized hole with a small hole acts as drip line as shown in figure below that can be elongated as long as the user needs and how far wide the garden area. I will show you how I simulate this system. As we can see here, that is a the flowchart of the system. We can use either push button or smartphone commands. In these smartphone commands, we can see that on-off buttons. When we press on the on button, the water spray will be turned on, and when we press on the off button, the water spray will be turned off immediately. At the same time, push button will do so, and when the button is pushed, the water spray will be turned on, and the push button is pushed again, and the water spray will be turned off. The dryer is used to dry the wet floor immediately after the mopping process. When disabled from a smart mop, it acts as an automatic hand dryer, which is commonly used in the kitchen and the toilet to dry users' hand faster. When an ultrasonic sensor detects hands, it conveys a signal to Arduino. As a result, the Arduino responds and sends the signal again to turn on the CPU fan, as shown in the figure. The hand will be dry immediately. When this part is attached with a smart mop, the function is to dry the floor immediately. Since there is no hand will be detected by the ultrasonic sensor, the alternative to turn on the dryer is by connecting the on-off button on the dryer so that the dryer will be turned on or off manually during cleaning. Here we can see the flowchart of a smart dryer working system. On the other side, we can see the circuit diagram of a smart dryer. This is the base of a smart mop, and this part also known as mop head, which is contact directly to the floor. This mop head can flip because it has dual features, that is dual-sided microfiber, and the other side is channels for wet and dry cleaning respectively. This mop channel side is especially great for pet hair pickup and sweeping the dust. On the other hand, the microfiber side features cleaning strip that permit for deep floor cleaning. The product concept based on Lego modular system, which is architects our product in such a way that the various components in it can be moved around and recomposed like Lego block. By taking an input process, it is give an output while abstracting the detail and complexity the people who use it. We should not worry about how a Lego block is made. The focus should be input this Lego component together to get the expected final outcome. At the same time, the design is able to enhance product modularity. Designing a modular product has many benefits, from manufacturing flexibility to reduce research and development (R&D) expense during product redesign. Design and development of a smart mop or cleaner that may lead to change the term of Internet of Things IoT to Internet of Everything IoE. This is due to multipurpose programming in parts in a smart mop, which can provide various benefits in daily life tasks. Product sustainability is very important due to sustaining the product in the market. Most of the parts produced in a smart mop are dismountable due to facilitating the maintenance and ease to clean. In Industry 4.0, maintenance is very effective because to ensure that the smart mop equipment is in working order. As a result, by applying the Lego concept on a smart mop, it is very effective in maintaining the capability of the system embedded inside the smart mop. This is proven when users just disassemble parts that face malfunction problem only and fix it without disturbing and damaging the other's part. Thus, it is easy for user to do either preventive maintenance or breakdown maintenance due to prevent work stoppage by equipment malfunctions. In a nutshell, not to forget about ergonomic design of a smart mop. The design is ergonomic and safety enough that ease user to operate the mop in order to make sure that the task completes with less time taken and no injury will happen. Plus, it should be functional properly when it is being operated. That means there is no error popping up during cleaning process. I'm pretty sure that this product is ready enough to be commercialized. With these special features, I'm surely can push user to buy with reasonable price. Smart mop manufacturer does not produce waste as well as byproduct. However, during the manufacturing and fabricating process, waste is only produced in tiny quantities. during inspection and quality control processes have prohibited inferior smart mop from being made on the production line. Most waste consists of microfiber trimmings and loss of fiber that produce waste. All the waste are completely disposed of and controlled. At the same time, the manufacturer is a danger from the waste and thus in keeping with the requirement of the Occupation Safety and Health Administration OSHA. Hence, this smart mop production does not produce in any hazardous and dangerous waste parallel to RoSH compliance.
This project is very clearly supportive for the culture to reduce working time and perform a vigorous role in sanitation of the nation as well as reduce fall accident.
Here we can see that the safety factor. Safety factor is the fraction between the strength of the materials and the maximum stress in the part. And the maximum of the safety factor of the part 1 is 15. And we can conclude that when the stress is in particular point becomes greater to the strength of the material, such as the factor of the safety ratio become inferior to 1, this this when where there is danger. When the stress in the part endures much inferior to the strength of the material, the safety factor stay greater to the one and the part is safe. Now we shift to the next result, which is static stress. Here we can see that the minimum stress is 0 pounds square inch. However, the maximum stress is 300 pounds square inch. That when the load is too heavy weight, where it is superior to 300 pounds per inch, the part will be ruptured and damaged, and as well as totally cannot be used anymore.
For the future study, I recommend that designer or manufacturer to embed hybrid technology system in cleaning tools so that it will lead to integrate Internet of Everything to Internet of Anything parallel to sustainable development too.
I think that's all for me. Thank you for watching. Thank you for your attention.